saw yesterday, sine and cosine, we know we graph from 0 to 2 pi, their interval is, or that's for their interval, their period is 2 pi. Tangent and cotangent were different, they only had a period of pi, and each of those had a special interval that we used. Tangent is from negative pi over 2 to pi over 2, and cotangent was 0 to pi. Secant and cosecant are going to be a lot like sine and cosine, because think about it, they're reciprocals. So that's the good news, you're not going to have any more weird intervals to remember. Tangent and cotangent are the only different ones. So let's look at our handout, and we are going to do cosecant first. Cosecant is the reciprocal of what? Sine. Okay, so if we think about it, sine of 0, if you're doing your hand trick or thinking about this, sine of 0 is 0, so what's cosecant? What's the reciprocal of 0? Undefined. At pi over 2, sine of pi over 2, remember sine is the y, so sine is 1, so the reciprocal of 1 is 1. At pi, sine is the y, so that's 0, reciprocal of 0, undefined. 3 pi over 2, so sine would be negative 1, that means cosecant, reciprocal of negative 1 is negative 1. And 2 pi is back to 0, so that's undefined. Okay, when we have an undefined, just like with tangent and cotangent, we have it in asymptote. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And at pi over 2 it was 1, pi is undefined, 3 pi over 2 is negative 1, 2 pi is undefined. Okay, really from those points, it's not much to base our graph off of. We could do more. We could put in all the other points here. But here's what I want you to think about. If we graphed sine, the points on sine were 0, 1, 0, negative 1, 0. If you draw this on your paper, just draw it really lightly. This is not the graph of cosecant, this is the graph of sine. However, cosecant is the reciprocal of that. So you'll notice we had asymptotes for cosecant. And those asymptotes are every time the sine was 0. My high and low points, my amplitudes, stay. What this does is it takes your graph and it flips it away from the axis. And so it actually just looks like two little parabolas. An upward parabola and a downward parabola. So the actual graph of cosecant is these parabolas. That little curve that I drew in is for sine is just to help you. My suggestion when we graph secant or cosecant, all we really have to do, we're really good at graphing sines and cosines. We can graph the sine or cosine and get the secant or cosecant just from that. So that will be how we approach these. The domain on this, we do have asymptotes, so we have values that x cannot equal. I'm going to put dot 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 because we know it keeps going, so there were values before this, but we saw it happen at 0, pi, 2 pi, and so on. Basically every multiple of pi, we have an asymptote. Our range, with sine and cosine we hit everything in between negative 1 and 1. This one's the opposite. It's everything smaller than negative 1, union everything bigger than 1. Okay, is this even or odd? Odd. It's a reciprocal of sine. Sine was an odd function, wasn't it? Cosecant is also odd. So that means if you have the cosecant of a negative, you can pull that negative out in front. So the only even function we've seen so far was cosine. Everything else has been odd. think about cosine. Cosine's the x. Cosine of 0 is 1, so reciprocal of 1 is 1. Cosine of pi over 2 is 0, so secant's undefined. Secant of pi is negative 1. Sorry, cosine's negative 1, so secant is negative 1. 3 pi over 2. Cosine is 0, so secant's undefined, and 2 pi is back to 1. Okay, again, if you're just looking at these points, kind of hard to tell what the graph looks like, but if we graphed cosine, cosine starts at 1, 0, negative 1, 0, 1. Again, we see those asymptotes happen where the cosine was 0. The high and low points stay. So what the actual graph of secant does is it flips away from the x-axis. So it's also just like those little parabolas. You're just alternating upward and downward parabolas. Now my graph kind of stopped at a weird spot, but if you continued it each way, it would just look like that. So is this one even or odd? Even. Just like cosine was even, secant is also even. Okay, domain. X cannot equal what? Yeah. Got pi over 2, 3 pi over 2. Next would be 5 pi over 2, 7 pi over 2. All those fractions there. Range, we hit everything smaller than 1 and everything bigger than positive 1. So, we are going to work on graphing these now. We have all 6 functions. Our strategy, what I recommend, we are going to treat this like a sine or cosine. Some people actually need to draw in the sine or cosine. Some people kind of know enough about the graph to know where the asymptotes are. I don't care if you actually draw the sine or cosine, but I'm going to treat it like that and use that to graph these. That way we're not learning something new. We're not trying to memorize where those asymptotes are going to happen. We can just go off what we're used to and extend it from there. So, here is our first example. Same questions as always. Amplitude, period, count by, so forth. So, what is my amplitude? 2. Period. We're back. When I see secant, I'm thinking about cosine. Normal period for cosine is 2 pi. Tangent and cotangent, you do a pi, but everything else you do a 2 pi, divided by the number in front of x, which is a half. I get a 4 pi. Count by period divided by 4 is pi. Do I have to do an interval? No. If you're confused about if you need to or not, just do it. Everything except tangent and cotangent you just set up between 0 and 2 pi. So if you multiply everything by 2, you get 0 less than or equal to x less than or equal to 4 pi. So for one interval, we will start at 0 and end at 4 pi. No up, down, flipping, or anything like that on this graph. So my interval starts at 0. That is my first point when my x is 0. Add your count by. So next would be pi, 2 pi, 3 pi, and 4 pi. Okay, what I'm going to do is lightly draw my cosine graph to help. If you draw in your cosine, make sure at the end I can tell what your answer is. So if you don't need to do it, you don't have to. If you do, either lightly draw it or erase it afterwards or highlight the actual secant cosecant graph, something so I know that you realize it's not part of the actual answer, it's just there to help you. So when we did cosine, we knew it started at its amplitude and then went down. So hit 0, -2, 0, and 2. So this was my cosine. So everywhere that is 0, we get what? So we'll have an asymptote here at pi and 3 pi. Then your high and low points stay, and you just flip it away from the axis. And remember, it's just a curve approaching your asymptote. So it should look like this. So my answer, just so we're all clear, is just this black curve. The green one was just to help me. If I asked for 2 periods, could you guys do that? Tack on 4 more points and keep the pattern going. So I think we're pretty good with that. Any questions? Let's do another one. One plus 3 halves cosecant of x minus pi over 2. So what function am I thinking about when I graph this?
Sine.
What is the amplitude?
3 seconds.
Period.
1. No, wait.
2 pi over 1, which is 2 pi. Count by.
Pi over 2.
Period divided by 4, so pi over 2. What does this 1 do?
Erase the graph I want.
Right, what's this doing?
0 and 2.
So everything except tangent and cotangent you just do between 0 and 2 pi. Alright, so if I'm solving for x, add our pi over 2. So 0 plus pi over 2 is pi over 2. 2 pi plus pi over 2, 5 pi over 2. Alright, let's draw this. So my first point will happen at pi over 2. Then you add your count by 5 total points. So plus pi over 2 is pi, plus pi over 2 is 3 pi over 2, 2 pi, and 5 pi over 2. We did go up 1, so I'm going to go to +1 and just draw in that line, so that's what we're moving above and below. Okay, I will start by graphing sine. Sine starts at its 0. So when my x is pi over 2, we will be on our line at 1. Amplitude is 3/2, so I go up to 2.5, back to 0, down 3/2 will take me to -1/2, and back to 0. If you need to draw in that line or that curve, you can. If you just want to leave it at the points, you can. It's whatever you need. But from here, we know where will I have asymptotes. Everywhere that you were on your 0 line, which was at 1 this time. So I have a vertical asymptote. Pi over 2, 3 pi over 2, and 5 pi over 2. High and low points stay, and then you just flip it away from the axis. So again, my actual answer is just this black curve. So just like graphing sine and cosine. Not really a whole lot new this time. Any questions there? Do we need more examples of graphing these? Let me know when you start your homework and if you can't figure it out. I want to do maybe a couple where I give you a graph and we write an equation to go with it. We did this for sine and cosine. I did not with tangent and cotangent. But since these are so similar to sine and cosine, I thought we'd try it again. So on A, if I want to decide if this is secant or cosecant, what you could do is draw in your sine or cosine. Anywhere where you have an asymptote, you know your graph was at 0. Your high and low points stay. So that green curve I just drew in, is that sine or cosine? Sine. So that means my curve is the reciprocal of sine, which is cosecant. So we have a cosecant graph. Is it flipped or anything? No. Is my amplitude different than normal? No. The only thing that is different is where it started and stopped. There are different ways to approach this. Since this one started at 0, we could just treat it as a period, but I want to talk about if I went from an interval. This graph started at 0 and ended at 4 pi. We know the normal secant and cosecant graph would go from 0 to 2 pi. What would I have to do to turn this into a 2 pi? So 0 less than or equal to x over 2 less than or equal to 2 pi. So x over 2 is my angle, or 1/2 x. So this first one is y equals the cosecant of x over 2. Okay, second one. So I would be at 0 here, except, am I? What happened to this graph? It moved up 1. It's centered right here. So I know already this graph went up 1. Would have been 0, high point, 0, low point, 0. So secant or cosecant? If it starts at 0, it's like a sine again, so it's a cosecant. And we know we need a +1, either at the beginning or end, because it moved up. Amplitude. From this line, we went 1 above and 1 below. So did we change our amplitude? No. Let's look at the interval. This one went from negative pi over 2 to 3 pi over 2. This needs to start at 0. How would you turn negative pi over 2 into 0? So we get 0 less than or equal to x plus pi over 2 less than or equal to 3 pi over 2 plus pi over 2 would be 4 pi over 2 or 2 pi. Do I need to do anything else? It's 0 to 2 pi like I wanted, so this is cosecant x plus pi over 2. Do we want any more of those? Nobody's going to say anything. I'll give you your homework and then you can ask me if you need help with it. So first 4 are matching, the next set you're drawing graphs, and the last ones are just some writing some equations and some true-false questions.